Hello everyone, my name is Mark. Welcome to my Calc 3 videos. Today we're going to talk about calculus of vector value functions. And once again, what is the most important thing in vector calculus, right? In my opinion, that has to go to parameterization, right? This is so important that I'm bringing it up again, and I'm sure you will see the same quote in the later chapters. Just you wait. So, what does the derivative of a vector function point at, right? According to what you have learned in your lectures, right? I'm pulling up my good handy lecture, my lecture notes. So if you can see here, right? So this is our vector value, the path of the vector value function, right? And this is your where the vector value function is pointing at, right? The location. So at this location, if you take derivative, right, you will see that this r prime of t is tangent to the curve. So let's go back. And then we have another set of questions. If a function describes the path of a particle, then what and where does the derivative mean and point at, right? So I think everybody understand that if the vector function describes the path, right, which is the position of the particle, the derivative is the velocity vector of the particle, right? So, right, remember you learned about in Calc 1, right? You take the derivative, it quote unquote becomes a velocity if your original function is a position, right? And it's pointing at, right, tangent to the curve, as we just have discussed before. So, what is the definition of a unit and normal vector, right? And more importantly, where do they point at? Okay. So if we go back, right, again to my good handy lecture note, right, this is how do you define unit tangent vectors. You have the r prime of t, right, which is your quote unquote velocity vector in some cases, and you also have the magnitude of the same vector, and you just normalize it, right? We call dividing a vector by its magnitude is normalizing, right? We normalize the tangent vector, right? That's why it has the name unit tangent vector. Well, in case you wonder what a unit normal vector is, I don't think this course teaches this anymore, but just in case they do, because I had to learn it, the definition of unit normal vector is this, right? You have your unit tangent vector that we just have learned about. We take the derivative of that again, and we normalize it, and we get a unit normal vector. And don't quote me on this, but I believe where the unit normal vector is pointing is pointing tangent to the unit tangent vector. So I think it's kind of like you're pointing to the center of the curvature of the curve at that point. But don't quote me on that, okay? This is just my intuition. But the equations are correct, and then the direction of the unit, the tangent vector, of course, also the little unit tangent vector, they are pointing in the same direction. Okay. All right. I hope that makes sense enough. All right. So let's go ahead and start solve some problems. So this one is coming from exam 1, spring 2018. I think, right, let the velocity vector becomes this, and you want to compute the magnitude of the velocity vector, right? I mean, this one is so straightforward that I don't even have a one-pager for you, but I just want to cover some basic calculus with you. So, to solve this problem, right, you're just gonna go ahead and integrate. Right, you're just gonna have to integrate each vector component right, to get v, and then you find v, right, the normal vector, the magnitude of v, right? I think everybody knows how to do that by this point, so I'm just gonna skip that, right? So it's step 1 and step 2, easy enough, right? I think everybody knows how to do calculus at this point, so I don't think I need to review that with you. And then here's the second question, right? Finding the angle between the velocity and the acceleration vector at t equals to 1 for the position vector r of t, right? So this one is a little bit interesting, but I think if you think about this for a few seconds, it's just a piece of cake. So what you really need to do is find velocity and acceleration vector. Find the velocity and acceleration vector. Right, so that is r prime of t equals dr dt, right? And you also have r double prime of t equals to dr square and dt square, right? So these are, I think it's pretty easy to do, right? If you know how to do this, you know how to do this backwards, right? And acceleration, you just take the derivative twice. So now you have r prime of t and r double prime of t. What we are going to use is something that we have learned in the first day of lecture, is the angle equation, right? So we have the equation of cosine of u dot v equals to the magnitude of u divided with magnitude of v, and then times cosine theta, right? So if you arrange this, theta just becomes cosine in a negative first. I'm gonna make a big bracket, u dot v, and then the magnitude of u times magnitude of v. Okay, so I would memorize these two equations so that you can, especially this one, because oftentimes the question will ask you how to find the angle between the two vectors. So I would memorize this modified equation so that you can pull it out really quickly on your exam, right? So I'm gonna save the answer choices for you, and this one is coming from exam 1 for 2019. Oh, by the way, it might sound a bit biased, but after helping students with over 2 years, that each semester students complain about me that, oh, we had the worst exam, we had a worst midterm, we had the worst exam ever. I was like, no, you don't. Because from my experiences so far, I believe fall 2019 exam 1, exam 2, and final exam are indeed the overall most challenging midterms and final. Okay, I hope that explains enough for you to how to solve this question. Okay, by the way, in this case, you can let u and v be the velocity vector and the acceleration vector. Doesn't matter which one is which, so just go ahead and substitute them in. All right, so the last one, right? Yes, the answer is D. I gave the question answered away, but let's go ahead and actually solve this question together. So let L, if L is the tangent line to the curve, or such at 3, 4, 2, find the point where L intersects with the xy plane. So, right, I think we have done this multiple times. The only thing that is different, right, I think everybody understands that this is finding the intersection between a line and the plane. But what's a little bit tricky about this one is that, the plane is given, right? The plane is just xy plane, and that just tells us the plane is z equals to 0. Well, what about the line, right? It's because it's asking for the tangent line, so the line is not the curve r of t. So to find the tangent line, what we are going to do is find the derivative r of t prime, right? R prime of t, right? So that just dr and then dt, right? So this is the vector, the tangent vector. And then remember, on the second video that I've made, right, 13.5, lines and planes in 3D, right, what do you need to define a line, right? You need a point and a vector. You need a point and a vector. And the point has to be on the line, and then the vector has to be in the direction which the line is traveling, right? Because it's a tangent line, we're looking for a tangent line. The tangent vector is the vector that's pointing along the tangent line, right? And then we also the question also happens to give us, happens to give us a point, right? Happens to give us a point, right? So this point is on the line. So, to find the tangent line, we're going to use. I'm gonna call this point. I'll just call them P, right? So L just equals to P plus your r prime of t vector, right? R prime of t, and then r prime of t at 3, 4. Never mind. You do need to find the t variable, right? So I think that's pretty easy to find, because you can just solve for this equation, right? So that's pretty easy, right? So t just equals to 2. So you can plug in t equals to 2 right here to find your r prime of t, and then r prime of t equals to 2, right? And then times t. This t is different than that t because this t is parameterizing the curve. This t is parameterizing our tangent line. So now we have the tangent line. We're just gonna use our mnemonic device, which is plug in the line into the plane, and we can solve for the intersecting point between the tangent line and the xy plane. How do you do that? I'm not gonna elaborate this twice because you can go back to my 13.5 video to learn how to do this. So I'm just gonna cover these questions quickly. So that's it for 14.2 calculus of vector valued functions, right? So we kind of just add a layer of calculus upon what we have already learned, and it's nothing that is super duper difficult, right? It's everything you have learned before. Now we're just kind of starting to combine things together and make the questions a little bit more interesting. And again, thank you very much for coming to watch my videos, and I hope you learned something, and I hope you, especially the process of solving these type of questions, right? The mindset of approaching these questions, and I will see you in the next video.